So we've got two equations. We've got our equation for heating and cooling. We've got our equation for phase change. C is known as specific heat. So I'm going to go ahead and put a C over here so that you know that that's specific heat. You use specific heat when you are heating or cooling. The key word there is heat in specific heat, okay? So that's your hint that you use it when you're heating or cooling. Phase change, the symbol for change is a triangle. So it's a good way to remember if you're going through a phase change, we're getting a change in enthalpy, okay? So enthalpy is that delta H. So we use that delta H for phase changes. So this is for heating and cooling, and this is for a phase change. Bless you. Question number 3 says, how much heat in kilojoules is required to heat 18 grams of water from 25 degrees Celsius to 110 degrees steam? So we're going to mark where these temperatures are at on this graph to visually be able to see exactly what lines we need to go through. So 25 degrees Celsius is going to fall somewhere between 0 and 100, about a quarter of the way up. So I'm going to say it's about here. So we're going to say that's roughly 25 degrees Celsius. And 110 is probably right about here. All right, so the next thing that we're going to do is we're going to count how many lines that we have to go through. So we have to go from 25 up to D, that's one line, through D and E, that's 2 lines, and E up to 110, that's 3 lines. So how many steps am I going to be writing down? 3, very good. Okay, I'm going to go ahead and start writing our steps down. What is my first step? Heating what to what? Liquid to gas, and I'm heating from what starting temperature? 25 up to? Not to 110. 100. Why can I not just go to 110? Because we have to go through a phase change, okay? So my very first step, I'm going to heat from 25 degrees Celsius to 100 degrees Celsius. Bless you. Because I'm heating, am I going to be working with enthalpy or specific heat? Specific heat. The symbol for specific heat is just C. That's where the MC delta T is. It's the C in MC delta T. What is going to be the specific heat for water that's at 25 degrees Celsius? 4.18. Am I going to write down J or KJ for this one? J. Very good. There's also a temperature change. What is my temperature change while I'm heating this? 75 degrees. Okay. What is my second step? Vaporization. I'm going to vaporize it. Is that a phase change? Absolutely. So since that's a phase change, am I working with specific heat or enthalpy? Enthalpy. My enthalpy for vaporization is going to be 44.01. Am I going to write down KJ or J for this one? KJ, because if you look at your sheet, there's a KJ next to it. Okay. What's my third step? Heat from what temperature to what temperature? 100 to 110. What specific heat am I going to use for this one? Gas. So that's going to be 1.84 joules. And what is my change in temp? 10 degrees Celsius. Very good. Any questions so far? No? Okay. All right. Next, I'm going to figure out exactly what equations I'm working with. So I have a heat, a phase change, and a heat. How many times am I going to use the heat equation? Twice. How many times am I going to use the phase change equation? Once. Very good. So, moved it down too much. Q total. My first one is heating, so I'm going to work with the MC delta T. My second step is a phase change, so that's going to be my N delta H. My third one I'm heating, so that's going to be another MC delta T. At this step, I also like to usually write down my mass and my moles. So my mass in my problem was 18 grams. So M is equal to 18 grams. How do I get moles if I have mass? Divide by molar mass. So the molar mass of water is actually 18. So what is 18 divided by 18? 1. So we've got 1 mole and 18 grams. The third step is to just plug and chug. So my first parenthesis is going to end up being 18 times 4.18 times 75. What am I going to write under this one? J or KJ? J, because this one is specifically working with joules. So I'm going to write a J underneath. My second is going to be 1 times 44.01. What am I going to write under this one? KJ. My third parenthesis is going to be 18 times 1.84 times 10. And what am I going to write underneath this one? J. All right. Simplifying these down, I'm going to end up having my first parenthesis is going to be equal to, sorry, I'm just looking at the, okay. 5, 6, 4, 3. What's going to be my unit for that one? J. Plus 44.01. What's going to be my unit for that one? KJ. Plus 331 J. Can I add these together right now? Why? They're not in the same unit. What unit do I have to change? I've got to change everything to KJ, so I'm going to change these two. How do I do it? Divide by 1,000. So I'm going to move the decimal 3 spots to the left. So I end up getting 5.643 plus 44.01 plus 0.331. And when I add all of that together, I end up getting roughly 50 kilojoules. Number 4 says, how much heat in kilojoules is required to heat negative 10 degree ice to 110 degree steam? So, where would we say negative 10 is at? Near what letter? A. So we're going to say this is negative 10. Okay, negative 10 degrees Celsius. And 110 is already written on here, right? So how many lines do I have to get through? 1, 2, 3, 4, 5. So how many steps is this one going to be? 5. This is a big one. None of them are any more than 5 steps. 5 is the maximum number of steps. So what I'm going to do is I'm going to give you guys 5 minutes, and I'm going to have you work with your tables to get those 5 steps out. Okay? 5 steps out. Once you get the 5. All right, so we have our 5 steps for question number 4. Now we need to figure out exactly what equations we're going to be working with. So if I'm working with heat, I'm working with MC delta T. The back table named it MCAT.
Yeah, MCAT. Woo!
MCAT, okay? If we're working with a phase change, they named this one NA. Okay? If that's a good way for you to remember it, then cool. So our first one we're going to work with MCAT. Okay? So we're going to have Q is equal to MC delta T. Our second one's a phase change, so that's a NA. N delta H. Our third one is another heat. We're heating, so that's another MCAT. Our fourth one is another phase change, so that is NA. And our fifth one is another heat, so that is MCAT. I had a really good question earlier. They said, Miss Deek, how do we get moles? Moles is going to be your mass divided by the molar mass of your substance. What was the substance that we were working with here?
Water.
Water. What's the molar mass of water? 18. So what I did to get my moles is I took 26 and I divided it by 18, and that gave me 1.44 moles. Okay?
Is it gonna be something different than water?
Flip your sheet over.
Yeah, it's like water.
Ethanol. Okay. Are you guys going to be okay if instead of me writing all of the numbers in the, I just write the answer to the parenthesis? Is that okay? Okay. So the answer to the first parenthesis that you should have gotten should have been 5408 joules. Roughly. Is that what we got? Roughly 5408. The second one should have been 8.65 kilojoules. The third one should have been 10868 joules. The fourth one should have been 63 kilojoules. And the fifth one should have been 478.4 joules. Are those the numbers we got? Or around those numbers?
Yeah, that was nice.
All right, what do I need to do at this step?
This is divided by 1,000.
Yeah, I've got to convert my J's to kilojoules. So I do that by dividing by 1,000 or moving the decimal 3 places. So my new numbers are going to be
Oh, you don't like it? You like fun. I know.
all right, so these are your new numbers. And then from there, after you've added everything together, you're going to get an answer around something in the 80s. Okay? I got roughly 83.9. But anything in the 80s is fair game, just depending on how you rounded. Okay? Any questions on this one? All right. If you flip your sheet over, go ahead and take a gander at that graph on the next sheet. Just absorb it in. Okay, so something I gave to you on this. This is a heating curve for ethanol. Is ethanol the same thing as water? No. Are the specific heats the same numbers? No. Are the enthalpies the same numbers? No. Are my temperatures for my phase changes the same? No. So this is quite different. Also at the top of this, I gave you guys the molar mass for ethanol. Okay? To help you with your mole calculation. So we're going to write a few things on this graph just so that we are all on the same page here. So we've got solid ethanol is going to be below negative 114 degrees Celsius. Do you guys see that? Anything below negative 114 is solid ethanol. What happens at negative 114 for ethanol? Fusion. Between negative 114 and 78.4, what state of matter is ethanol?
Heat.
Heat, yes, it is heat. But the state of matter is liquid. It's okay. At 78.4, what happens to ethanol? It can vaporize. And then above 78.4 degrees, what is it going to be? A gas. Okay. So let's make some markings on this graph so that we can figure out number 5 together. It says on number 5, how much heat in kilojoules is absorbed when 20 grams of liquid ethanol at 0 degrees Celsius is vaporized? All right, 0 degrees Celsius for water is solid water. Is 0 degrees Celsius in ethanol solid ethanol? No, it's not. 0 degrees would honestly probably be right about here. 0 degrees Celsius. Do we see that? If I want it to completely vaporize, am I going to go all the way to through the gas state? Am I going to end up here or at the end of this line? End of that line. Very good. So this is completely vaporized. How many lines is that? So how many steps is number 5? 2 steps. So you have your starting point, you have your ending point. With your tables, I'm going to give you guys 5 minutes to do the entire calculation for number 5. I think you guys got it. Okay? The entire calculation for number 5, and then I will put it up at the end. How many steps is this one? A solid 2 steps. Step number 1, I'm starting at 0 degrees Celsius. What am I heating that up to? 78.4. So step 1 is heating from 0 degrees Celsius to 78.4 degrees Celsius. Because I'm heating it, am I working with specific heat or enthalpy? Specific heat. This is liquid at 0 degrees Celsius because we already marked up this whole graph. So which specific heat am I going to use? The liquid, 2.44. So my C is 2.44 joules per gram degree Celsius. What is going to be my change in temperature for this one? Yes, 78.4. Okay. Step 2. Once I've reached 78.4, what happens on my graph next? Vaporization. What is that classified as? Phase change. So step 2, we're going to vaporize. Because I'm vaporizing, I'm going to be working with delta H. I'm going to use the one for vaporization. So 38.56 kilojoules is going to be my delta H for this step. Any questions right now? Next, we're going to figure out what equations we need. So our first one's heat, so that's going to be what? MCAT, right? So this one's going to be an MCAT. What's going to be my next one? What's going to be my next one? Nah. Okay. So you don't have to write them out in a list like I did. You could write them next to your thing as well. And that's what I'm just showing you guys here. It's however you like to do these, okay? Something else I also need to figure out is my mass and my molar mass. So my mass is 20 grams. So that's my mass, 20 grams. I need to figure out my molar mass, which was given to me up top. So the molar mass is 46.07. So I'm going to take my 20 grams. And I'm going to divide it by 46.07. And that's going to give me 0.43 moles. And that's what my N is. Okay. All right. Next, we just plug and chug. So MC delta T, my very first one is going to be 20 times 2.44 times 78.4. That's going to be joules. Plus N, which is 0.43, times delta H, which is 38.56. This one's kilojoules. When I simplify that out, I get 3825.92 joules plus 16.58 kilojoules. What do I need to do with my joules? Divide it by 1,000. So 1, 2, 3. When you add those two together, you should get roughly 20.41 kilojoules.